Hello my dear fan, hope you are well. Today we are going to discuss a very important topic, and the topic I hope that this topic will more familiar to you. The topic name is equilibrium of forces. You know well about this equilibrium of forces. You know, if number of forces acting on a body, then we call the body is in equilibrium when the net addition of these forces vectorially gives a value 0. For a better understanding, let's consider this is a point mass. This point mass is acted upon different force F1 in this direction, F2 in this direction, and F3 in this direction. Then if I am taking this F1 vector plus F2 vector plus F3 vector, which gives a value 0. That means net addition of this each vector gives a value 0. That is F1 vector plus F2 vector plus F3 vector gives me a value 0, which means that this body or this point body is in equilibrium. Please note that the addition is vectorial addition. This is very important. If you are adding like this vectorially and you are getting the value as a sum is equal to 0, then the body is in equilibrium. Now I would like to ask you one question regarding this state of this point object. Yes, will this point object have a state of motion even though this body is in equilibrium? That is my question. Can you able to answer this one? Yes, I know you have sure about if this body is in equilibrium, then if I am stating that this body have a state of rest, then you will say, yeah, it's okay. It's looking good. Okay. But if I am saying that this body is in equilibrium, but I am saying that the body is in motion, will it happen? Yes, you may have a doubt. Let's clear this doubt in this lecture. This is a very interesting topic. Let's start this topic from the basics. First of all, you need to understand that this equilibrium have two subparts. And the first subpart is static equilibrium. And we will discuss about the static equilibrium later. And we have another subpart as dynamic equilibrium. If you are able to understand the static equilibrium, dynamic equilibrium separately, then that is the answer for this question. Okay, let's start our journey from here. First we will discuss about the static equilibrium, then we will come to the dynamic equilibrium. For the static equilibrium, let's consider a 2 kg block. This 2 kg block is placed on a perfectly smooth surface. You can take this is a 2 kg mass, and if I am applying a force of 3 Newton in this direction, so you can see this is 3 Newton which is acting by an external agency or external person on this direction, in the positive x direction, and here another person is acting the same force 3 Newton in this negative x direction. So please carefully look this figure. You can see there are two forces, that is 1 3 Newton in this positive x direction, 1 3 Newton in negative x direction. Can you give me what is the net force acting on this 2 kg block? Yes, from this figure you can directly say the net force is 3 minus of 3 gives a 0. So here net force is 0. So this is a validation of this equilibrium state, because net addition of these forces gives vectorially gives you have the value 0. So which means that this 2 kg is in the state of rest. Then I will call this type of equilibrium as static equilibrium. Static equilibrium, which means that this body is not moving, but the net force acting on this body is 0. Okay, now let's understand about the dynamic equilibrium. It's quite difficult or quite complicated related to this static equilibrium. For that, let's consider this is a perfect smooth surface. This is a straight. Okay, and here I have shown a 2 kg block, and this 2 kg is acted upon a force of 2 Newton. So as you know from this figure, the body is acted upon an external agency of force 2 Newton. Please note that at initial speed of this 2 kg as 0 meter per second. So the body is starting from the rest because of this 2 Newton is acting on this 2 kg mass. So the body will start to move in this posterior x direction, or the body will start to move with some acceleration in this posterior x direction. So first of all, you know that the body is acting upon a force of 2 Newton on a mass of 2 kg. So there will be an acceleration developed. What would be that acceleration? You know, acceleration is given by net force by total mass. Here the net force is 2 Newton. And here the mass is 2 kg. Just putting this value, you will get an answer 1 meter per second square. So the body will start to move with some acceleration, that is 1 meter per second square. Okay, so that after some time the body will reach in another position and it will cover some distance and it have some velocity also. Now we are going to focus the motion of this 2 kg block, especially the motion of this 2 kg block. Okay, so you know this body is moving with some speed in this direction, so the body will reach here at t equal to 2 seconds. Can you give me what would be the velocity at here? Yes, you know from the equation of motion you can write like velocity. Final velocity gives initial velocity plus acceleration into time. Please note that continuously this 2 Newton is acting up to t equal to 2 seconds. So here also you can see that 2 Newton. Okay, so the velocity, the final velocity you need to calculate is given by initial velocity. Yes, initial velocity is 0 plus acceleration of the body gained due to this 2 Newton external force is given by 1 meter per second square. I am just putting this value, yes, 1 into time. Time is 2 minus 0 because initially the time is 0 second. Okay, I forgot to mark here 0 second. Please note that initially we are starting at t equal to 0 second and t equal to 2 second is the final time. So t equal to 2 minus 0 gives 2. Just putting the value you will get 2 meter per second. So as you know, the block is moving with some speed 2 meter per second. I will just explain the condition again one more for a better understanding. Here we have the static or the rest is 2 kg block, but I am just applied a force of 2 Newton and this force is made by any external agency. I am not going to research on that. Okay, let's analyze the motion of this 2 kg block. Yes, here we have the 2 Newton forces acting, so which develop an acceleration of 1 meter per second square. So the body will start to move with some acceleration, so the body will gain some velocity, because this is an accelerating body. Okay, then the body gains a velocity 2 meter per second at a time 2 equal to 2 seconds, and the same force 2 Newton is acting at that moment t equal to 2 seconds. Now I am just going to study the motion of this 2 kg block at a t equal to 2 seconds to 3 seconds, but not that in this study at a t equal to 2 seconds I just removed this 2 Newton force. So which means that here I just removed that 2 Newton force at accurate t equal to 2.0001 second, which means that when the time reaches above this 2 seconds, above just a small increment in the time above than this 2 seconds, then I am just to remove that force. So can you give me what would be the net force acting on this body, on the same body of 2 kg? Yes, as you know from this figure, when you remove that force, the net force becomes 0, which means that at t equal to 2.0001, the force becomes 0. That means net force becomes 0. Then what would be the acceleration? Yes, acceleration is given by net force by mass. Here the net force becomes 0, which means that 0 by 2 gives 0 meter per second square. Hope you understood? From the time changes to 2.0001 second, or infinitesimal increment in time, then the force is released. Then the net force becomes 0. Then acceleration becomes 0 meter per second square. Then the acceleration becomes 0 meter per second. Now we are going to find the velocity of this block at here. I take this velocity as v. We want to find this velocity. So for that, let's bring that equation of motion again. As you know, as I am just writing here, yes, final velocity is equal to initial velocity plus acceleration time. Yes, what would be the initial velocity? Yes, we are considering the motion from this 2 to 3 second area or that space. Then initial velocity is 2 meter per second plus the acceleration become 0, because when the time moves a little increment greater than this 2 seconds, then I will just remove that force, which means that the acceleration becomes 0. So this is the acceleration. Here we are just putting this value 0 into time. Time is 3 minus 2 gives 3 minus of 2, which gives a value 2 meter per second. Here the body will move with the 2 meter per second. So let's analyze the forces acting on this 2 kg block. Okay, please look at this figure carefully. Then you can see this is a 2 kg block. And is there any force acting on the horizontal direction? No. The net force acting on this 2 kg block is 0 at this position. Then this body is moving with some speed 2 meter per second. Even though, let's carefully examine this 2 kg block. The net force acting on this 2 kg block is 0. But the body is moving with some speed 2 meter per second. So here we have the net force F is equal to 0, but the state of this 2 kg block is in the state of motion because it is moving with some speed of 2 meter per second. So which implies this body is in the state of motion. Then this type of equilibrium, actually this is the type of equilibrium because the net force acting on this 2 kg block is a 0, but the body is moving with a constant speed or a constant velocity. Yes, so we call this type of equilibrium as the dynamic equilibrium. Dynamic equilibrium. Hope you understood. We have defined first static equilibrium, then this type of condition, because the net force acting on this 2 kg block is 0 in vectorially. If you are adding this vectorially, then you will get this is 0, but the body is moving with some speed 2 meter per second. At t equal to 3 seconds, this is the speed. What will be the speed at t equal to 4 seconds? Is again it would be moved with the same speed 2 meter per second. If there is any increment in the speed, which means that an additional force will come there, so the equilibrium will be lost. Okay, please note that this type of equilibrium we call dynamic equilibrium. Actually, this can be made a little more easier way. I will explain that too for you. For that, as you know, from the Newton first law, the force is given by mass into acceleration. This is the Newton first law. Then the force can be written like mass into acceleration can be written like v, final velocity minus of initial velocity divided by time. Okay. Then if the force becomes 0, that means external force or the net force becomes 0, then m, the same m, final velocity minus initial velocity by time is equal to 0, which means that final velocity is equal to initial velocity or initial velocity is equal to final velocity. Let's understand about this one. Initial velocity is equal to final velocity. Then I can explain this equilibrium condition. This is my equilibrium condition because net force is 0, which implies final velocity is equal to initial velocity. So I am getting an equation like u is equal to v. Now let's go into study about this u is equal to v. Yes, suppose that u is equal to 0. U is equal to 0 meter per second. Then what would be the final velocity if a body is in equilibrium? So from directly you can say u is equal to v. So final velocity become also be 0 meter per second. This is the one condition. If suppose that u is equal to 2 meter per second, any value 2 meter per second, then final velocity, what would be the final velocity? Yes, then it should be 2 meter per second if the body is in equilibrium, because you know when the body is equilibrium, this force becomes 0, which means the final velocity is equal to initial velocity. So here the body has an initial velocity 2 meter per second and the final velocity also be 2 meter per second. Then these are the two conditions. Okay, one, this here we have no values, but here velocity have some values, initial velocity have some value. This type of equilibrium, that means initial velocity and final velocity is 0, then this type of equilibrium we call static equilibrium. And this type of equilibrium, this means the net force is acting on this body 0, but the body is moving with some constant speed or the constant velocity. Then we call this type of equilibrium as dynamic equilibrium. Okay, hope you understood. These are the main two parts of this equilibrium. Here we have the static equilibrium, then we have another type, dynamic equilibrium. Actually, please understand that if a body is in equilibrium, which doesn't mean that the body is in the rest. It may be in the rest, it may be in the motion. It depends upon whether that equilibrium is static or dynamic. Hope you understood. This is very important idea needed for your conceptual questions in mechanics. Hope you understood. Thank you.